And so it'll happen both in triangles and in other sets of parallel lines that are just the angle measures of parallel lines being cut by a third line. So we're going to start with the concepts involving the triangles, where you have a side parallel to the base or the one of the sides of your triangle. Okay? And so this is referred to as the triangle proportionality theorem. And it says that if you have a line that's parallel to one side of a triangle, if it intersects the other two sides, then it divides those two sides proportionally. Okay, and we've discussed what dividing proportionally means, that they have the same ratios. Okay, and so what that means is if you have this relationship right here where you see that these two lines are parallel, then that means that the ratio of QT to TR is the same as SU is to UR. And so the way that I kind of set that up is I will think of the parallel line kind of as a fraction bar. So if I set this as a fraction bar here and here, just through that parallel line, if I thought of this being X, Y, and then Z and W. And if we think of those segments of the triangle sides that are cut off, what it means is that basically this ratio right here and this ratio right here are equal to each other. So again, I use the parallel line as an equal as well. And so I would get the relationship here that X over Y is equal to W over Z. And so that's the relationship that you'll see. The ratio of those sides are going to be equal. Okay, so if you could find what would be the measure of YZ if you have the given sides based on that triangle proportionality theorem. So when you set up the ratios, you're going to set up the ratio of the two parts of one side equal to the ratio of the two parts of the other side. And so again, if I'm going to go ahead and give this a variable here, A, just to designate. But what I'm going to do, or the way I visually solve these, is I take my parallel line and I just kind of extend it out as a fraction bar. And then I'm going to set those two fractions equal. And so what I'm seeing here is that 27 over 81 and A over 54 are equal to each other. Okay, and so if I just take that, I will generally start with the variable, my unknown, in the top of my fraction, because you can do it in any order. So I'm going to take A over its the remaining portion of that side, 54. So here's the sort of fraction I'm starting with. A over 54 is equal to, I write my little equal to symbol, and then I take my other fraction. And again, whichever part I start with, I'm starting with the part that's on this side of the parallel line. So I have to start with the 27, the corresponding piece there, over the other side, 81. And so this is my fraction. If I multiply both sides by 54, I get my answer. Remember, you can enter your answer as a calculation. So I could have entered this as my answer. If I simplify, 81 and 27 have a common factor here. You might not be familiar that 27 or 81 is a multiple of 27. So you would likely see that 9 goes into 81 9 times, 9 goes into 27 3 times, 9 goes into 54 6 times, 6 times 3 gives you 18. Like I said, you could have entered it as a calculation or have done the calculation and entered your resulting value. All right, the second part to this is just the converse, and that says that if you do have, if two sides of a triangle are cut off in equal ratios or proportionally, then it means that that line is parallel to the other side. So here's how that would be written. If a line divides two sides of a triangle, proportionally, then it is parallel to that third side. Okay, and so here, if you have the relationship, if QT over TR, the two parts of that side, QT over TR is equal to the ratio of SU over UR, then you know that TU is parallel to QS. And then those sides are parallel to each other. And so that's what these last remaining questions here are asking you to confirm. Based on what you see right here, is PS and QR parallel in those examples. So I want you to compare those two, both of these two problems here, see if you can figure out yes or no, these are parallel lines based on proportional parts of those sides. Okay, so again, what you're looking at is if you take the ratio of these two sides and set them equal, is that a true statement? So is 21 over 13 equal to 28 over 20? And you could have done 13 over 21 equals 20 over 28. Whichever way you set it up is fine as long as it's consistent. And whatever side here 21 is on, it's to the left of this parallel or this side PS. So you'd have to start the other side with 28. And if you simplify this, what you can see is here 4 goes into 28 7 times, into 25 times. 3 goes into 21 7 times, but it doesn't go into 13. So there are no common factors to reduce 21 over 13. And so what you see here is that these are not equal. Not equal means that they're not parallel to each other. If we take the other side on this other side, I'm going to start on this side first. So if I take 20 over 40, and I'm going to see is that equal to, I started with 20, so the side on the, or the portion of that other side that's on the same side as the parallel of this PS line is 8. I'm going to see is that equal to 8 over 16. 20 and 40 have a common factor of 20, so it reduces to 1/2. 8 and 16 have a common factor of 8, reduces to 1/2. So here I do have that relationship. These are proportional to each other. Therefore, the answer is yes, these are parallel lines. Right, so the first few questions are kind of covering that type of a relationship. In addition to working with triangles, this same kind of idea holds true for multiple parallel lines. Okay, and that is if you have 3 parallel lines, and they intersect 2 different transversals. Remember, a transversal is a line that intersects multiple lines. Then that means that they're going to divide the transversals proportionally. Okay, and so basically what this is saying is that if line R is parallel to S and parallel to T, if those are 3 parallel lines, then the conclusion is that the ratios of these segments are going to be equal. So this segment and this, or when you take the ratio of these segments here, you have equal ratios, okay, which means if I take W or UW over WY versus VX over XZ, those are equal to each other. So once again, I'm going to use the parallel line as a fraction bar, kind of put an equal between. And what I see here is that UW over, so this portion right here, over Y or WY is equal to, since I started with W, I have to use this portion here from VX over XZ. And so those are equal ratios as well. All right, so I'm going to, again, talk through this first one and then have you do the second. So the way that I set this up is if you're being told that these are parallel lines here, here, and here, okay, then you know that these are set up as ratios. So if I set a fraction bar along that parallel line, put an equal sign in there to help represent, to just visualize my ratio, what I see is that 42 over 24 is equal to 14 over y. And now if you wanted to, you don't have to write it visually in the same order here. You could put y over 14 is equal to 24 over 42. You can set it up that way. But just because this one is set up where you can visually see that relationship easily. And what you would do here is you could cross multiply. 42y is equal to 14 times 24. Divide by 42. Notice I'm not doing the math yet because I can enter my answer as a calculation. So again, ideally, I'm entering this as my answer. But you can reduce what you have. I mean, if you're working through to reduce this, what you can do is you can say that 7 goes into 24 6 times, 7 goes into 14 twice. 6 goes into 24 4 times. 2 times 4 gives you 8. So you get y is equal to 8 for your answer. So again, you can leave it as that calculation, which I do recommend, or you can perform the calculation on your own. All right, so try this second problem here on this slide. And can you find what w is using that same relationship? And so once again, it's visually, these types of problems here are set up to easily help you see what the ratios are that you need to set equal. So you have these parallel lines here. Therefore, it means that the segments cut off by those parallel lines are proportional. And so the way I would see it is that middle parallel line I just use as a fraction bar, and I know that those are equal. And so I get the relationship that w over 28 is equal to 24 over 56. And so on this one, to isolate my w, I just multiply both sides by 28. And that's how I would enter my solution. And if I was simplifying this, 56 and 28, again, what I would see is that 7 goes into 56 8 times, into 28 4 times, which means 4 goes into 8 twice. 2 goes into 24 12 times, and so I get my answer to be 12 by doing just some simple canceling of factors. All right, so those are the two proportionality theorems that deal with parallel lines. This last one's going to be dealing with an angle bisector and how of a triangle and how that relates the segments and sides. And so here's what this is stating. If you have a triangle and a ray bisects one angle, then that ray is also going to divide that opposite side. Into two segments whose lengths are proportional to the lengths of the other two sides of the triangle. All right, so that's the wording part of this. The statement says that if ray CD bisects angle ACB, then the following relationship holds true. Okay? It means that here's my fraction bar, that AD over DB is equal to the ratio of these other two sides, AC and CB. And so that's the way that will be set up. I'm going to remove these pieces here. Okay, but that is here's your fraction bar again. AD over DB is equal to AC over BC, okay, when you set that relationship up. So again, if I walk you through this first one, okay, if you have this angle bisector right here, then that means that here's my fraction bar, x over 72 is equal to, since x comes on this same side as the 24 is to 36. And so there is my equation. Multiply both sides by 72. Once again, once you get your calculation, you're good. If you want to simplify, 36 goes into 72 twice. 2 times 24 is 48. So you can multiply your answer as well. But that's how you would set it up and solve. And so try that last example. See if you can find what the value of x would be, or the length tu in that example there. So once again, you can write your fractions in either order, right? Up here I could have said 72 over x equals 36 over 24. But just to be like somewhat consistent here, the way I talk about this is I extend that angle bisector, becomes a fraction, so I see that this is 27 over x, and that's equal to 27 corresponds to the 18. X here is going to correspond to that 24. And so there's my ratios. And so for this, again, you're either going to cross multiply, so 18 times x is equal to 27 times 24. Notice, if you ever see me cross multiply by hand, I won't multiply it out. I don't take what 27 times 24 is. I'm just leaving it as factors, because that allows me to cancel factors rather than trying to simplify or cancel entire numerical values. And so here, if I see 18 and 27 have a common factor of 9, 9 goes into 18 twice, into 27 3 times, 2 goes into 24 12 times. So 3 times 12 gives me my answer here of 36. So I could have either left my original calculation, 27 times 24 over 18, or my calculated value, and that would give me the answer for this problem.